All right, so here we are. So we've just completed the factor tree to show the prime factorization of 18. Then up here in expanded form, we've written out our primes multiplied together to equal 18. And then over here, we've used powers now to express the primes with their exponents to figure out now how many factors there are. So we brought down that exponent, we added 1, and it became a 2. And on this side, we brought down this 2 and added 1, and it became a 3. When you multiply those two numbers together, you get 6, and that tells us what we need to know for the factor rainbow at the bottom. We use the factor rainbow to get all the pairs of factors that can be multiplied together to equal 18. So what I'm going to do is, just for the sake of making this as simple and clear as possible, is I'm going to draw 6 circles. Why 6 circles? Well, my number of factors up here is 6, so I know that I want all factors represented down here in the rainbow. Okay. Now, eventually you'll be dealing with bigger numbers that might have as many as 24 factors. It's a lot harder to fit those all into this space, so you might need to use some other paper on the side to do these calculations. The first thing I like to do is always put 1 and the number itself on the factor rainbow. Every number has those two factors, 1 and itself. So 1 times 18, okay, this rainbow arch basically represents multiplication. 1 times 18 equals 18. So that means 1 and 18 are factors of 18, okay? Now, how do I figure out what goes in these other 4 blanks? You could probably do it with mental math, but I want to show you how to do it using the factor tree. So I look back at my prime factors and I ask myself, do I see a 2 represented in this factor tree? Boom, right there. Yes, so I know that 2 is going to be a factor, and 2 times some other number will equal 18. Okay, but I'm going to move this way first. The next one I want to look at is the number 3. Is the number 3, can it be represented with primes? Absolutely it can. You can see a 3 right there. So 3 times some other number will equal 18. Next, I might try 4. Can I multiply together any combination of these prime numbers to equal 4? No, I can't, because 3 times 3 is 9, 2 times 3 is 6, so clearly 4 cannot be made by multiplying together any of these primes. If I had another 2 somewhere, then yes, I could do that. But in this case, no, not going to happen. So does 5 work? Well, 5 is a prime number, and it would be represented in this tree somewhere if 5 was a factor of 18, which it's not. How about 6? Well, if I look at these 2 factors here, if I just block off one of the 3's, and I only look at 2 and 3, I can see that 2 times 3 equals 6, and 6 is definitely going to be the next factor that's represented. And it also completes that part of the rainbow. 3 times 6 does equal 18. We know this. Awesome. So again, if I keep moving through the numbers, we've got 6. I cannot see a 7 anywhere in this factor tree. Okay, 7 is a prime, so it would be circled. It was in here. How about 8? You cannot multiply any of these primes together to equal 8. So 8 is not in there. The last potential factor that we see is 9. 3 times 3 equals 9, which you can see in your factor tree. So this blank ends up becoming 9. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. So all these pairs of factors multiply together to equal 18. And 1, 2, 3, 4, 5, 6, we know we have all the factors of 18 because we already calculated up here how many factors 18 in fact has. Okay, so now we'll just move on and we'll practice with a bigger number.